formal introduction of our Humboldt Prize winner and Hermann Otto Hirschfeld lecturer, I would like to introduce you to Dean Oliver Günther, and he will speak to you about this tradition and about
Yeah, dear Junking Fan, dear colleagues, dear guests, Wolfgang Hertle asked me to say a few words about to you at the beginning of this lecture, and I'm very happy to have this opportunity because the Hermann Otto Hirschfeld lecture is really a very important thing for our department. It's had now a couple of years tradition, and it represents some of our focal areas and some of our roots in an excellent way. On the one hand, statistics, econometrics, the focus areas of Wolfgang Hertle, Nikolaus Hautsch and their groups, which was at the beginning of the Hermann Otto Hirschfeld lecture, they are really at the root of this School of Business and Economics, not only talking about the school post-1989, but the school as it was founded actually 130 years ago, because the first time we can really talk about economic research at Humboldt-University, that was in 1876, when the Friedrich-Wilhelms-Universität started an activity in economics. Yeah, it doesn't work. When the it was in 18th. Ah, that's much better. Okay, but I spare you to repeat you all the details. But yeah, so we're really talking about the roots of this school, because in 1876, when economic research first started at this university, it was really a research activity in statistics that started it all. Then economics joined kind of this spectrum of disciplines, and business only came much later, actually about 100 years ago, when the Handelshochschule, the private business school here, was founded, and this building was set up to house the Handelshochschule. So statistics is really at the root of this School of Business and Economics, and after 1989, as you all know, the founding fathers of the new school decided to maintain this emphasis, and this is why we have such world-renowned colleagues like Wolfgang Hertle, like Helmut Lütgepohl, and now like the new generation, Nikolaus Hautsch, here at this department. The lecture, especially as we are having it here in this wonderful chapel, also represents the roots of this department in a second way, namely in terms of how the department, how the university fits into the history of the city. You're sitting in actually one of the oldest buildings of Berlin, the oldest church of Berlin in particular. This chapel, as some of you may know, has been set up 800 years ago, and despite several situations where it was almost destroyed or taken away in order to make room for something else, it was kept, and it withstood all the different political situations in which it was set. The most dangerous point for the chapel was actually also 100 years ago when, as I just mentioned, our building was set up. As I said, back then not as part of the university, but as a private business school. And back then the chapel here was in such bad shape that people thought we should just get rid of it. And then there was actually a protest by the people of Berlin to keep the building, and that's why it was integrated into the new building. And then later, much later, redone to be as beautiful and as usable as it is today. So in this way, I'm very happy to welcome you all to the Hermann Otto Hirschfeld lecture. It represents the strengths of our school in a very nice way, and I'm very happy also to welcome again Junking Fan as a featured speaker. But before we're going to have Professor Fan, there will be several others who will greet you. So have a nice afternoon.
Actually, I'm not sure whether you make this joke about Hartley or should I say it? Okay, I make the joke. When I was a young grad student, a very famous statistician from Chapel Hill, his name is P.K. Sen, came to Heidelberg at the Sonderforschungsbereich 123, and I was a young grad student, so I had to do some calculations for him on a big IBM 360. And then, of course, he acknowledged me and that's when I first came over over this name Hartley. He acknowledged me. I would like to thank Dr. Wolfgang Hartley, Hartley. Right? So this is interesting. The second time I saw this when I visited Ray in the 80s, he was department head at Texas A&M, and I knew that he has started an H.O. Hartley lecture, but it took me another 10 years to create this idea here, and then of course go back to the old name Hermann Otto Hirschfeld. And it's my pleasure, and I'm delighted to announce to you that Ray Carroll, another Humboldt Prize winner of this faculty, is here today, and he will talk about this H.O. Hartley lecture tradition in Texas A&M for a few minutes.
So I don't know how many of y'all know that Hermann Otto Hirschfeld became H.O. Hartley when he moved to the United States. He originally took up a position at Iowa State in the middle of the country, and this is a picture of him that I got from the Amstat News. And then he came to Texas A&M in about 1963, as it'll show. Everybody at Texas A&M and in the United States called him Ho, H-O-H. At least he kept his initials. And what was interesting about Hartley was, besides the fact that he made me and Wolfgang look like giants, he was so small, you know, and I really liked Hartley because I could look down at him. Some of his former students who have become very, very famous, still even now, at age 60 and 70, call him Dr. Hartley. They just revered him both for his mind and also for his kindness and his generosity to others. He came to A&M in 1963, and he basically was part of the vanguard of changing TAMU is how we say Texas A&M University. It was a cow college there were cows on the campus, and it was a military college too. It was not a research school. He was recruited by a guy named Earl Rudder, and who was also very small, and they became quite good friends. Rudder was the president of Texas A&M at the time, trying to change A&M from a teaching and military school to a real university. Hartley came as a distinguished professor, and there's only about 35 distinguished professors at A&M even now. A&M has an interesting history. I happen to be from Northwest Texas, and Texas A&M was all male, all military, lots of cows. And my sister was in the second or third class that they admitted women, and there were 20 women in her class. She said she had a date every night when she was in there. And it was a tiny little town, you know. It was definitely not Berlin. There were 15,000 people in the metropolitan area. There may have been a decent restaurant. As a college student, I didn't think so. So it was a really tiny little place. And 9,000 students, now there are 45,000 students at A&M. He brought in 4 people and founded the Institute of Statistics, as it was called, later the Department of Statistics. He left with, when he retired, there were 16 faculty, not 4, which was quite a large number for those days, and he had 60 graduate students. He supervised 30 PhD students, some of them very good friends of mine who really have done great work. He bought a ranch, and just after he died, or just before he died, he sold the ranch when he moved to Durham, North Carolina, to a colleague of mine named Jim Mattis. And about 4 years later, they found oil, and it was really a lot of oil. And so Hartley was just a few years before his time. Jim Mattis is a very wealthy man now, lucky him. Okay, so you know he was really a great guy, and I met him when he was at Duke, and also in visits to A&M. He's really helped make my department a great place, because a lot of the old-timers, when I went there, they remembered Hartley. They remembered this little guy who was smart, and now we have 35 permanent staff and 100-plus graduate students. It's great to be here. I was here 11 years ago for my first Humboldt Professorship Award, and here it is again. Thanks.
Thanks, Ray. Okay. I usually introduce Hermann Otto Hirschfeld's life here with these slides, but after my little presentation and the presentation of Zhenjin, we will have a very new novelty here at the Hermann Otto Hirschfeld lecture. I'm delighted to announce that Dr. Annette Vogt from the Max Planck Institute for Wissenschaftsgeschichte, Historical History of Science, has agreed to give a longer talk on the life of Hermann Otto Hirschfeld and his family and the roots of Hermann Otto Hirschfeld here in Berlin. You will hear, for example, that Hermann Otto Hirschfeld by family links is related to the Springer Verlag, a very important science editor. That's why I make this very short, and I jump directly because you will see all these transparencies later. I will jump directly to the presentation of Zhenjin Fan. Zhenjin Fan made his Bachelor of Science at Fudan University, a very renowned university in Shanghai. Then moved to Beijing, and 1989, I think this was the first time when I saw him. He made his PhD at UC Berkeley. And 89, he moved to the UNC, Chapel Hill, where also Ray Carroll was. I think Ray Carroll was just left 87, and then Zhenjin came. Then Zhenjin Fan moved to Hong Kong, the Chinese University of Hong Kong, and stayed on leave always from Chapel Hill, was professor in Los Angeles, and finally in 2003 became professor in the Operations Research Financial Engineering and Bentheim Center at Princeton University. Since 2006 he is the Frederick Moore Professor of Finance at Princeton. Now, in 2005, during an Oberwolfach meeting, I developed the idea that we could have some relationship between Princeton and Humboldt, and to make this relationship also scientifically solid, I proposed him for a Humboldt Prize, and he won that. And part of this cooperation was that he agreed to co-organize the so-called Humboldt-Princeton conference that was just happening this weekend. And today he is the Hermann Otto Hirschfeld lecturer, and I will show you how Zhenjin Fan is commemorated in this university. So we have such a plaque here, so you see your name here. You see the former lecturers, so Steven Stiegler, for example, last year, Frank Debo 2 years ago, and Paul Embrechts and Joel Horowitz. And we also have you, I also give you Urkunde that signed by the Dean and signed by myself as director of CASE, the Center for Applied Statistics and Economics. You see this sign here. Would you please come up here? So is there a picture prepared to? So let's give him a hand here. Okay, good. The program, as I told you, I'm delighted to announce this program change. We'll have now Dr. Annette Vogt talking about the history of Hermann Otto Hirschfeld, the roots, how he became a statistician, how he changed his name from Hermann Otto Hirschfeld to H.O. Hartley. That's why we have a change in program. So after, this will be about 40 minutes. After that, I'm sure you will be happy to have some coffee outside. So there's coffee outside, and then you come back, and then Zhenjin Fan starts with his lecture. So now let me see, where is your, here? Anton? Brenda? This one? No.
No, this is still yours.
This is PowerPoint. It was, huh? Ah, in the folder. In the folder? No, here. Up.
This one.
This one. Okay, great.
It works.
It works.
Okay, let's welcome Otto.
Dear colleagues, thank you for coming and thank you to be interested in who is Hermann Otto Hirschfeld. And in memoriam Hermann Otto Hirschfeld Hartley, and we learned already HOH, as friends called him, and as she was widely known, is meant to consider the life and fate of this extraordinary statistician. He was one of the most interesting statisticians in the 20th century, who was able to combine pure and applied methods, who was able to solve simple practical problems as well as to create new topics like his voluminous statistic tables. And he was an organizer in science too. We heard already about his work at Texas University. And his center became one of the centers of statistics in the USA. He was a great mentor not only to his students but also to his colleagues, as William Smith pointed out. And we heard already there is a Hartley Memorial Lectures at Texas University, and also Hartley Award is given from 1980 onwards. And this Hermann Otto Hirschfeld lecture was established 4 years ago. With these lectures, Hartley comes back to the town where he was born and where he received his PhD in mathematics shortly before he was forced to leave Germany and to go into exile. Little is known about the years of his childhood and youth in Berlin, his study of mathematics at the famous Göttingen University and at the Berlin University. He was born in Berlin on April 13 in 1912 in the family of German Jewish roots as son of Harry Hirschfeld and Elisabeth born Springer, belonged to the publish house, the science publish house Springer. He had 2 brothers, Philip and Fred, and 1 sister, Dorothy. His father, Harry Hirschfeld, and this is the only entry about him which I found in this dictionary about jüdische Richter und Staatsanwälte in Preußen during the Nazi time. His father studied law, and in 1900 he received his PhD at the Jena University with a study about a specific law for landlords. So the German title is Das Pfandrecht des Vermieters an den eingebrachten Sachen des Mieters nach gemeinem Recht und bürgerlichem Gesetzbuch. He had to convert to the Christian religion to get a position in the public legal system. This was necessary because of the normal anti-Semitism in the German Kaiserreich. The baptization was the entrée billet to the bourgeois society, as Heinrich Harry Heine wrote, although in his personal case it didn't work. Until 1933, Harry Hirschfeld made a successful career, and you see here where he was. In the year Hermann Otto Hirschfeld was born, he was Amtsgerichtsrat in Spandau, and then he directed Landgericht I in Berlin as Landgerichtsdirektor. So Hermann Otto Hirschfeld got the good education children of bourgeois family got in these years. Thanks to his short biographical sketch, the CV, and you see here the first part of the CV, and it had to be written before the PhD examination, and it was published together with the PhD in these old times. So he started in the Kant Gymnasium, and then he attended the Bismarck Gymnasium in Wilmersdorf. And here, as you could read, he clearly pointed out, hier hatte ich in den höheren Klassen Herrn Professor R. Fuchs zum Lehrer in Mathematik, der mein naturwissenschaftliches Interesse in hohem Maße gesteigert wurde, durch den gesteigert wurde. So as a historian of mathematics, of course, immediately I thought, who could be R. Fuchs? And I knew that in the end of the 19th century, a very important mathematician here at the Berlin University was Emanuel Lazarus Fuchs. From 1884 until his death in 1902, he was full professor for mathematics. He also had to convert to the Protestant religion in 1860 to get a position as a teacher in the public high school in Berlin, which was impossible for a German Jew. And one of his children became a mathematician too. Exactly, Richard Fuchs. You see here some of the stations of his life and work. He got the PhD at Berlin University, the Habilitation at the Technical College Technische Hochschule Berlin-Charlottenburg. And although he was a private docent, he can't live from that money, so he had to teach in a high school to earn his living. And although he also was außerordentlicher professor at the technical college, he had to teach too, luckily for the schoolboy Hermann Otto. Thanks to his work for the German Association for Aerodynamics and Aircraft, Deutsche Versuchsanstalt für Luftfahrt, he survived the Nazi regime and the persecution in the hard winter in 1945. He died only a few months after the liberation of his country. It is unknown whether the schoolboy Hermann Otto Hirschfeld knew that his beloved teacher in mathematics, Richard Fuchs, was the son of the famous Immanuel Lazarus Fuchs. But the influence Richard Fuchs made was definitely an important one for him to study mathematics and science, especially physics. So first he studied in Göttingen, and you see in his CV he mentions the name of his Göttingen professors and then also the names of his Berlin professors. So who were the academic teachers at the Göttingen University? He mentioned especially Richard Kurang, Edmund Landau, James Franck, the Nobel Prize winner, and Robert Pohl. 3 of these had to fly from Germany. Göttingen, in this time, was the mecca for mathematicians and theoretical physicists from all over the world. It was the most attractive place for American guests as well as from other countries. Among others, Göttingen was visited by the American physicist Robert Oppenheimer, the Soviet later United States physicist Grigori, and later George Gamow, the mathematicians Alexandrov, Kolmogorov, Schnirelmann. Norbert Wiener came from the USA and Dirk Struijk from the Netherlands. So here he had a really good education. And then these 3 colleagues who were displaced from the Göttingen University, Richard Kurang and James Franck, escaped to fly to the United States. Richard Kurang was the most important mathematician in Göttingen who influenced HOH also to choose the topic of his dissertation. And these are the academic teachers of the at the Berlin University. Probably he changed the university because of the beginning of Nazi terror. In the little town Göttingen, the SA troops were louder and more visible than in Berlin, where still anti-Nazi forces were active. In Göttingen, the famous Emmy Noether had to change her apartment already in 1932 because she was a Jew. The capital Berlin was less dominated by the Nazis, although in Berlin SA troops marched through parts of the town too. Jewish people or human beings who looked Jewish were beaten. In the case of foreigners, it was a little scandal and reported in some newspapers, then an excuse was made. Who wanted to see the danger could recognize it. Among the first were the writers Joseph Roth and Kurt Tucholsky. In Berlin, HOH studied very quickly, finished his study, wrote his dissertation, and already in February 1934 passed the examination. Here you have all the names of the teachers he mentioned in his CV. Richard von Mises, Erwin Schrödinger, Isai Schur are the emigres among those mathematicians and physicists who had very different conditions for their exile. And luckily, HOH could finish his study in 1934. In 1935, it will be forbidden for Jews by the Nazi definition, without independently of baptization and all other things. This is the official formula which was made when you have to make the examination. Hirschfeld sent his thesis direct methods of variation calculus to solve boundary value problems to the faculty. In that time, still the philosophical faculty. The division into the philosophical faculty and the math science faculty will be made only in 1936. And he asked for the examination. This is his letter. Ich wünsche in folgenden Fächern geprüft zu werden. I asked for the examination in the fields mathematics and physics. It seems clear. And philosophy, this was necessary at the Berlin University. In the archive of the Berlin University are kept all materials of the doctorate procedures of every candidate, the CV, the references of the thesis, the minutes, records of the examination, a duplicate of the doctor diploma, and, unusual in other university archives, a copy of the thesis. So one could reconstruct the procedure not only in the case of HOH. The records of the examination, Promotionsprüfung, this is a document the professors wrote themselves, handwritten, their questions, not the answers of the candidate, and the result. Here you see the first page. This is Hammerstein and von Laue in mathematics and in physics, and on the other side, the other wrote their notices. And one detail from this examination, Promotionsprüfung, clearly shows the conditions under which he had to finish his study. During the examination of Hermann Otto Hirschfeld on February 8, 1934, Ludwig Bieberbach asked the following questions. Geometrical methods in the theory of functions, the genus, uniformization, hyperbolic geometry, Möbius group, geometry of circles of Laguerre, the theorem of Desargues and connection, the theorem of Desargues and triangle, complete quadrangle, the circle of Feuerbach, the circle of Steiner, the geometrical ruler and compass construction, the tendency of P, the construction of Steiner, the construction of Malfatti, the isopermetric problem. Could you answer these questions? And the question is, could any student in mathematics immediately know the answers in 1934 when all these geometrical details belonged to theories which were created until 1830 and which were completely outmoded already in 1934? So from history of mathematics, it is known that Edmond Nicolas Laguerre worked only about very specific geometrical problems. His 2 volumes oeuvre was published in Paris in 1898. Girard Desargues in 1639 developed a theory of connections from the projective point of view, which became known in 1820 thanks to the publication of Jean-Victor Panquelet. Karl Wilhelm Feuerbach, the elder brother of the philosopher Ludwig Feuerbach, he published in 1822 a pamphlet about remarkable points of the triangle, über die merkwürdigen Punkte des Dreiecks, where first was described the 6-point circle and later this 9-point circle which became Feuerbach circle. And finally, the Swiss mathematician Jakob Steiner. In 1834, he became a professor at the Berlin University and a full member of the Berlin Academy of Science, and his geometry, the Steiner geometry, played a role in the middle of the 19th century. His colleague Karl Weierstrass edited the collected papers in 1881-82. Steiner gave a geometrical solution of the isopermetric problem, and he published in 1833 his geometrical rule in compass construction. And he also gave the first solution of Malfatti's problem, not Malfatti construction as Bieberbach asked for. The Malfatti problem is, a right-angle triangle is given, construct 3 circles of contact, that the area of the circles will be a maximum. In 1934, only historians of mathematics were still interested in these topics, but neither Ludwig Bieberbach nor Hermann Otto Hirschfeld were historians of mathematics. Furthermore, Bieberbach didn't give a lecture about history of geometry and Hermann Otto Hirschfeld didn't attend it. Therefore, it shows clearly the nasty kind of questions Bieberbach asked him. And please believe me, I studied hundreds of protocols, of records of these examinations because of other research reasons. It was unusual and untypically for Bieberbach himself between 1920 and 1945, and it was untypically for all these examinations. So it was really unfair. But it's no wonder Ludwig Bieberbach, from 1933 onwards, was a loudly speaker for the Nazis. He held his lectures in mathematics in 1934 in SR uniform. He created in 1936 a German mathematics, his Aryan mathematics, and he was not only a propagandist of Nazi ideology and politics, he also made denunciations against his colleague Isai Schur, against students and doctoral students during his time as the dean of the MathNet faculty. But HOH managed the examination very well. Here you see the other results who had given him. Hammerstein was his advisor in the thesis. Erhard Schmidt was the second advisor. Wolfgang Köhler, the philosopher, he had to emigrate to the United States too. And it's an interesting little remark. Erhard Schmidt later in the 1960s remembered the dissertation of HOH, and he said to another mathematician, Maximilian Pinnel, that the nicest result Hirschfeld had covered in one footnote. Zu seiner Dissertation bemerkte Erhard Schmidt, dass Hirschfeld sein schönstes Ergebnis in einer Fußnote versteckt habe. I studied the thesis before I prepared this lecture, but I couldn't find which footnote Erhard Schmidt meant. And furthermore, unusual for mathematical papers in that time, the Hirschfeld thesis included 37 footnotes. His thesis, Direct Methods of Variinitial Calculus to Solve Boundary Value Problems, was published in Schriften des Mathematischen Seminars und des Instituts für angewandte Mathematik der Universität Berlin. In the introduction, he clearly wrote, es sollen im Folgenden neue Existenzsätze für Variationsprobleme mit der Methode der Differenzengleichungen begründet werden. He referred to Leibniz, to Euler, who developed what was later named Euler differential equations, and he made the notice that thanks to Richard Korang, a rebirth of the direct method happened. Korang was obviously the most important figure for the thesis, and Hirschfeld mentioned some other mathematicians. From their work he took something to use: Levy, Bäbler, Tonelli, and Graf. After getting his doctor diploma in May 9, 1934, HOH was able to leave Berlin, to leave Germany, and to go the uncertain way into exile. His career began at the Berlin University with a PhD, but it was abruptly ended by the Nazi regime. Like many scientists with Jewish roots, Hermann Otto Hirschfeld was forced to flee Germany. Between 1933 and 1938, only in Berlin, in total 22 mathematicians, 3 women and 19 men, were forced by the Nazis to leave their positions at the Technical College in Charlottenburg and at the Berlin University. When the first campaigns and small pogroms in Germany were organized by the Nazis in 1933, on April 1st, for example, against Jewish shop owners, physicians, advocates, only few people predicted the awful future. It was unthinkable what would later be named Shoah. On April 1 in 1933, a law was introduced which allowed the exclusion of all Jews from any advocate in lower positions. This so-called law excluded his father, Dr. Harry Hirschfeld. On April 7 in 1933, the so-called Law for the Restoration of the Civil Service, Gesetz zur Wiederherstellung des Berufsbeamtentums, was introduced. This law was the basis from which all political enemies and all Jews could be moved from every position in the institutions of the public service system, from schools, colleges, technical universities, from the institutes of the Kaiser Wilhelm Society. And also it was applied not only to civil servant, Beamten, as the name implied, but concerned all Jews from the full professor to the assistant, including secretaries and technicians, who never belonged to the Beamten status. This law excluded in Göttingen the teachers of HOH as well as in Berlin, and this law was modified several times, and then the last step was the so-called Nuremberg law in autumn in 1935. This so-called Nuremberg law cancelled civil rights for all German Jews, made them second-class citizens, and it was the basis on which all Jews from institutions of the public service who were still employed thanks to the exception rules were removed now. From Berlin, Hermann Otto Hirschfeld went to London, from London to Texas, but he escaped. And fortunately, it was possible for him not only to work and teach in his exile, but becoming an extraordinary statistician and scientist. Beginning in April 1933, displaced German scholars tried to emigrate. And in London in April 1933, The Academic Assistant Council was established, later became the Society for the Protecting of Science and Learning. And in New York in 1933, the Emergency Committee in Aid of Displaced German Scholars was founded. Thanks to these organizations and to the Rockefeller Foundation, German, later European refugees received support mostly in form of grants and fellowships. And the Academic Assistant Council published this list in 1936, list of displaced German scholars. In total, there were 1,624 scholars. Among these, 60 mathematicians were named, and it is one of the basic documents for every research in exile until today. Hermann Otto Hirschfeld is not mentioned here in this list because he had no position at the Berlin University. He was a postdoc, we would say. Because of further research, he was mentioned in this International Biographical Dictionary of Central European Emigres, and this is the entry you see. Compared with other entries, the lack of any private information, nothing about his parents, nothing about his family, his wife, or his children, this is very unusual. About 15 years before, Maximilian Pinnel, a mathematician who was persecuted by the Nazis too, was the first who studied in Germany the fate of Jewish mathematicians and who were thrown by Nazis and who were persecuted. And he published his results in the annual reports of the German Mathematical Society. You see here he mentioned all the persons who were displaced from technical college and from the Berlin University. And he has not included Richard Fuchs, so even Pinnel didn't know at that time the fate of Richard Fuchs, but it has included Hermann Otto Hirschfeld. And this is the entry about him, and here you see that Erhard Schmidt said, Hirschfelds schönstes Ergebnis ist in der Fußnote versteckt. And Pinnel got these informations personally from Hartley. You see in the footnotes that he was in contact with HOH. In 1934, Hermann Otto Hirschfeld emigrated together with his brother Philip, an advocate and solicitor, to Great Britain. In 1938, their mother Elizabeth, with the younger two children, reached the British coast too, but unfortunately his father stayed still in Nazi Germany. He died in the horrible year 1938, when the pogrom called Reichskristallnacht was organized. Looking from today, Harry Hirschfeld had luck. He died in his bed. In December 1937, Philip and Hermann Otto Hirschfeld changed their name into Hartley, and both were British citizens too. This made their life much easier. Other emigres were stateless or still Germans, and then in autumn 1939, in the beginning of the World War II, they were arrested as enemy foreigners. After leaving Nazi Germany in 1934, HOH began a postgraduate study at Cambridge University. He published very soon 4 papers, and in 1940 he obtained a PhD in mathematical statistics from Cambridge University. Obviously, because of the different conditions for mathematicians in Great Britain, he changed his scientific interest from pure mathematics to applied mathematics and statistics. Like HOH, many emigres had to do so, and the younger emigres among them studied again like he did. In 1940, he married to Grace, and the 2 children, Michael and Jennifer, were born in London. Only little mathematics was demanded when Hartley became a statistician from 1936 to 1938 at the Harper Adams Agricultural College. He was involved with poultry experiments, and he lectured on basic statistical methods to students of agriculture. Soon he became a consulting statistician, and at Harper he met his future wife and lifelong support, Grace. In 1938, Hartley joined the company's Scientific Computing Service, founded by the table maker Comrie, who was known by Carl Pearson. Carl Pearson was the prominent British statistician, the founder of the first English University Department of Statistics at University College London, where his son Egon Sharp Pearson spent up to his retirement in 1960. The younger person will become a close colleague of HOH. Both will edit and publish the famous famous table work, Biometrica Tables for Statisticians. Volume 1 came out in 1954 and Volume 2 only in 1972. During the years between 1938 and 46, Hartley had to do, as Herbert Aaron David wrote in his obituary, I quote, war-related projects, including large-scale surveys and the preparation of bombing tables for US Air Force flying missions over Germany and occupied Europe. Working in this company during the war years, HOH met Egon Pearson, and then it began their very successful cooperation and collaboration. Only after World War II, Hartley got an academic position. In 1946, he became lecturer in statistics at University College London. In these years, the field statistics and mathematical statistics were much better developed in the USA, and the opportunities for statisticians in England were very limited. Thus, in 1953, HOH moved to the US. Whether it was a second emigration or not, it was a deep break, a move to another culture as well as to another lifestyle. But again, HOH managed this very successfully. This is volume 2 of this table, coming out in 1972. From London to Texas. So first, we heard already he was visiting professor at the Iowa State College from 1954 until 1963. He was here professor of statistics. And then in 1963, he became the director of the newly formed Institute of Statistics at Texas. He built his initial faculty in the institute from 4 to 16, we heard already, and in the end he had 60 students and supervised 30 PhD students. Then he was going into retirement, and it followed a short term as visiting professor of mathematics at Duke University in Durham. HOH received several acknowledgements. He was well known for his work on the foundation of sampling theory, and in 1979 he became the president of the American Statistical Association. Before he served as president of the Eastern North American region of the Biometric Society. He published more than 120 papers. In 1978, Herbert Aaron David edited the volume in honor of the 65th birthday of HOH. Their list of publications is included. The major research Hartley made to the area of survey sampling. Together with Rao, a new estimation theory for sample surveys was developed. He also made numerical-oriented work. I quote David, "It was typical of the Hartley approach to the extensive manipulations on the function to be tabulated so as to make the computations as economical as possible. Here, his knowledge of both classical and numerical analysis was invaluable." One has to underline that volume 1 of this famous Biometrica tables was made without any help of high-speed computers. Only volume 2 draws heavily on computer-generated tables from many sources. The 2 volumes, with their attractive layout and useful introductory material, are models of table making, David pointed out. Thanks to the collaboration with Arthur Greenwood, in 1962 their Guide to Statistical Table was published. Hartley wrote some 10 papers on the use of calculators and computers. These constitute a current history of statistical computing over the past 40 years. Beginning with the Comrie-style paper read to the Royal Statistical Society, repeatedly he would assess the change in statistics brought about by modern computers. He was an expert as well in mathematical programming and contributed articles in linear, nonlinear, and convex programming. About his personality, William Smith and Herbert David reported with warm memory. David pointed out, I quote, "Hartley's ability and broad knowledge, coupled with a friendly, helpful manner, gained him the respect and affection of numerous colleagues and clients. These qualities also made him a superb major professor. Hartley gave unsparingly and generously of himself and did so with enthusiasm and charm. He loved his work. The statistical profession owes much to his brilliant man who was an inspiration to all who knew him." And I would like to finish with a kind of legacy of Hermann Otto Hirschfeld Hartley. He made a presidential address in 1979, shortly before his death, when the annual meeting of the American Statistical Association is normal. And this presidential address could be read as his legacy, and so I would like to end my talk with quotations of him, which I'm thinking are still actual and are still to think about. Hartley started with the question, what is statistics? And he discussed 6 topics: the science of statistics, the balance between mathematical and applied statistics, the cooperation between statistician and subject matter specialist, the problems of data acquisition, the impact of computers on statistics, and finally, the identity of the statistical professions. So it's interesting, furthermore, that in the short presidential address, he quoted 2 times Winston Churchill, from May 1940 until July 1945, Prime Minister of Great Britain and one of the leaders of the anti-Nazi alliance during World War II. So first, the science of statistics. Statistics is indeed a science, but of course most statisticians are professional people who apply this science to their subject matter problems. Many of us just use statistics as a toolkit and only rarely find it necessary to develop new tools, new statistical methods required to solve our real-world problems. It is a comparatively young science, although our historians have uncovered many interesting forerunners centuries ago. Statistics is, in a sense, the antithesis of the classical deterministic science. But the science of statistics cannot be identified with the calculus of probability. The mathematical aspects of statistics are only a part, often a small part, of its effective application. I now turn to the controversial problem concerning the distinction between applied statistics and mathematical statistics. Ideally, of course, there should not be such a distinction, and I would say he was such an ideal type. The difference between applied and mathematical statisticians is one of accepted priorities. The professional statistician is predominantly concerned with applied problems. We often hear the argument that pure mathematical research in statistics with no application to real-world problems is unnecessary. But it is extremely dangerous to be short-sighted and prevent all activities that do not immediately contribute to the social problems of our generation. The only way for a statistician to be effective is to cooperate with a subject matter area specialist. The data problems. This is a critical issue with which most professional statisticians must deal. Some of this information may be available from so-called official statistics sources, but it is vital to also have information on the limitations affecting such data sources. We would be reckless to assume that there are no errors in the data that we have managed to acquire. On the impact of computers, modern statistics is heavily dependent on the high-speed computer. From a mathematical point of view, the problem of error detection is essentially unsolvable, simply because the number of all positive error patterns is combinatorially of an astronomical magnitude. I'm now addressing the growing concern about the identity of the statistical profession, the concern about justifying our very existence. We must convince our colleagues in other areas that they would be wasting their time dabbling in statistics in an do-it-yourself extravagance. And convince we shall. And let me close with an analogue to the well-known wartime exhortation by the British statesman Winston Churchill: we shall fight in the colleges and universities, we shall fight in federal and state agencies, we shall fight in all public and private sectors of our economy, we shall never surrender. Thank you.